So in the previous video we looked at how to use the factors from, or the factored form of a polynomial. Well, today we're going to look at, in this video, we're going to look at how to use what's called the factor theorem. You want to make sure you get this factored theorem in your notes. It says the factor theorem is this, that x minus r is a factor of a function if and only if r is a zero of the function. So yesterday what we were doing is we took something that was already in factored form, or we got something down to factored form to figure out what these zeros were. Well, this time they're going to do the opposite. This time they're going to give us the zeros, or the x-intercepts, and we want to come up with a factored form, or we want to come up with the standard form of an equation. So like in this example, let's say we're given these x-intercepts. Let's say we want to find an equation in standard form that has those x-intercepts. So I'm going to use this factor theorem. Here's what I'm going to do. Remember, I already know that these are x-intercepts. So remember what we talked about yesterday, that x-intercepts, that term is the same as zeros. Those terms can be used interchangeably. So if I know that -3 is an x-intercept, I know that it's also a root. So that means that x minus -3 would be a factor of the polynomial. So x minus -3, well, a better way to write x minus -3 would be x plus 3. So that would be one of my factors of the polynomial. Another factor of the polynomial would be x minus 5, since we know that 5 is one of the x-intercepts. X minus 5 would be a factor. And since I know 12 is one of my x-intercepts, I would know that x minus 12 would be one of my factors. Again, I'm using the factor theorem here. Okay, so once I know the factors, now I'm going to do the opposite of what I did yesterday. Now I'm actually going to multiply these together. Now we can multiply these in any order. I could multiply the first two terms and then take that answer times x minus 12. Or I could take the last two terms, multiply those together, and then take x plus 3 times that polynomial. And actually that's what I think I'm going to do here. So this x plus 3 I can't forget about. But what I'm going to do is I'm going to take and multiply the x's, or the x times x to the -12, so that gives me x squared minus 12x. Now I'm going to take the -5 and multiply that times the the x and the -12, so -5 times x and -5 times -12 give me -5x plus 60. But I want to combine like terms here, so the x squared is going to stay the same. -12x minus 5x, that's minus 17x, and then plus 60. Now what I want to do is I want to multiply these two polynomials together, the x plus 3 times x squared minus 17x plus 60. I could do it in a similar manner to what I did here, or remember what we learned about at the beginning of this chapter, was that I could, in the second lesson, so I could multiply it like this. Now when I do that, x times x gives me x cubed. X times -17x gives me -17x squared. And x times 60 would give me 60x. Now the next row I'm going to multiply everything by 3. So this will be 3x squared minus 51x plus 180. When I write this now in standard form, my answer would be x cubed. The x squareds we add together, so that's going to be minus 14x squared. The x's, we add those together. 60 minus 51 is 9, so that's 9x plus 180. So this would be my equation in standard form. If I were to graph this, which I'm going to in a second, you're going to see that you'd have the x-intercepts of -3, 5, and 12 if we did it correctly. So now before we go to graph this, let's remember that, again, our x-intercept, the largest x-intercept is 12, my smallest is -3. My y-intercept, if I were to put 0 in here for x, my y-intercept would be a positive 180. So I want to make sure I take that into consideration when I go to graph this. So in that way, hopefully I can see the complete graph. Here's what I mean by that. Oops. Let's go to our calculators. So what we're going to do is this. We're going to type in that, well, before we even type in the equation, let's change our window settings. So I'm going to go to Menu. We're going to go to where it says Window and Zoom. The first option is Window Settings. Remember, my smallest x-intercept is -3. So I'm going to change this to be -5, just because I want to have a little space. I don't want -3 to be on the edge of my graph there. I want to give myself some space. So I'm going to have -5 as being my x minimum. My maximum, remember my largest x-intercept is 12, so I'm going to go a little bit more than that. I'll put in 15. Leave these as auto. For my y minimum, remember my y maximum, well, let's start with that one. My y-intercept is at 180. So I'm just going to bump that up to 200 just to make sure that it fits. Where I can see my my y-intercept. So just to be symmetrical here, we'll just do -200. Hit OK. So there's our grid. So now let's type in the equation. The equation you should have written down is x cubed. Remember that after you do the cube, after you raise it to that exponent, right now my cursor's up in the air. Hit the arrow to the right to bring your cursor back down again, and then it's minus 14x squared plus 9x plus 180. And hit enter. So now it's nice because we can see our complete graph. And now let's look to see where x-intercepts are. Our x-axis, they're counting by ones here. So this would be at -3. This is at 1, 2, 3, 4, 5. This would be at 6, 7, 8, 9, 10, 11, 12. So we have -3, 5, and 12 are 3 x-intercepts. And that's what we wanted to have. So this would be a good example to show you that the x-intercepts are the same as the roots and are the same as the zeros there. Let's go back to our notes. What we're going to do now is I want you to take a minute. You might want to pause this video to write down these 4 different equations. Because what we're going to do with these equations is we're going to graph them all in the same grid to see what we can learn from this. So here we have, actually let's do this just to mix it up a little bit. Let's make one of these. See how that changes things. Okay, so let's graph these 4 equations. So I'll go to your graphing calculator. Go to a new graphing screen. So what we want to do first before we get started is we're going to change our window to go from, they would give us this, but it's -5 to 5 is what we'll change this to. We'll change our y minimum to be from -100 to 100. And now we're going to graph those 4 equations. So the first one, now by the way, I'm going to type this in the wrong way first. If you were to type it in exactly like this, x times x plus 4 times x minus 3, you're going to get an error if you type it in like this. It says cannot accept the change, invalid output. If you notice, after you hit enter, they put a time symbol here, but they didn't put one over here between the x. So I don't know why it does that, but every time you put in x times something, it's always best when you have parentheses just to go ahead and put the time symbol in there. And that's your first graph. Let's look at the next one. So to graph another one, we would hit the tab button. So now it's going to be 4x times x plus 4. Oops, I forgot my time symbol. Times x plus 4. And then we had the square outside of it. And then times x minus 3. And then we had that squared. So that's interesting. We don't get to see the complete graph, but you see something unique there. Let's look at another one. Hit the tab button, and then let's do x squared, and then times of x plus 4, and then times x minus 3. Enter. And hit tab one last time and put in the last equation, which is negative 1/4 x squared. It's going to be times x plus 4 times x minus 3. So we move some stuff out of the way here so we can kind of see what's going on. It's nice having the color screen, so if you have that, it makes it a little easier to be able to see the different equations, because they have it kind of color-coded not only with the graphs but also with the corresponding equation. But look at all these. Even though all the graphs look the same, they all have the same x-intercepts. They have an x-intercept of negative, this point here would be at negative 4. Here's 0. This is an x-intercept of a positive 3. So they all have those 3 x-intercepts in common, but the graphs look completely different. So that's a good lesson, because what that means is that just because we know the 3 zeros, if I was given the 3 zeros of, or the 3 x-intercepts of 0, negative 4, and 3, just coming up with just a simple basic equation like this one, x times x plus 4 times x minus 3, using that factor theorem, gives us just one of the many possible equations I could come up with. So that means that we need to have another equation. We need to have what's called the general form of a polynomial. And this is how I like to write it. So the general form of a polynomial is represented by this: k times x minus r sub 1 to the a power times x minus r sub 2 to the b power times x minus r sub 3 to the c power. Now when we write something in general form, we're only going to be putting numbers where I just highlighted. The rest of it will stay the same. And the reason why is because, just like we showed, if I know the zeros, there could be situations where maybe I have an exponent, or maybe I have a number out in front. Those two pieces will not change what the value of the 0 is. It just changes the way the graph is. But we have to keep that in consideration when we're asked to write the general form of a polynomial. So here would be your answer for this particular scenario, where we have zeros of negative 7/2, 1/4, and 2. So it would be x, using that factor theorem, it's going to be x minus r, so it'll be x minus negative 7/2, or x plus 7/2. But remember, we could have a k or an exponent in front of it, so a number or an exponent there. Now I go to the next root, so it's going to be x minus 1/4 to some exponent possibly, times x minus 2 to some possible exponent. So this would be the general form for the polynomial with those 3 zeros. Now, that's enough for our notes, but what I do want you to do is print out your assignment on Moodle, and we're going to look at a couple of the problems there just to help get this sunk in for you. Now, the way that the worksheet is set up, I cut and pasted from a couple of different assignments there, so that's why the numbering looks kind of weird. But we're going to look at this particular 7, where it says, gives us these zeros of 6, 1, and negative 2. We're going to answer these questions. The fact that I have 3 zeros tells me that the smallest degree of the polynomial must be at least 3. And you'll see why in a second, because let's write a possible third degree equation. So if I have x minus 6, so I'm using the factor theorem, times x minus 1 times x minus negative 2, which would be x plus 2. This would be a third degree polynomial if I were to multiply all these together, because x times x times x would be x cubed. That's what we learned about in the very first lesson. Now it says write a possible fifth degree equation for the same function. So we're not going to have any extra added parts here. We're going to keep these same zeros. We only want to have these 3 zeros, but we want it now to be a fifth degree polynomial. Here's how I do that. I'm going to put some exponents where a, b, and c would be if we had this in the general form, which we'll look at next. So I could put 2 here and 2 here and just leave that one. Because now if I were to look at this, x squared times x to the first would be x to the fifth, which would make that a fifth degree polynomial. I could also have put a 2 here, leave that one blank, so there'd be a 1 there, and a 2 for the last one, because that would be x squared times x to the first times x squared, and that too would give us a degree of x to the fifth, so a fifth degree polynomial. Or I could even put a 3 as one of the exponents and leave the rest the same, so leave them all as to the first power, because x cubed times x would also be x to the fifth power. So there's a lot of possible ways that we could write a fifth degree equation here. Notice how it doesn't say to write it in standard form, so technically we could leave it just like this. Now when it says write the general form of the equation, it would be, could have a number out in front, so it'd be k. We could have any exponent for the x minus 6. That's an a, by the way, not a 9. We could have any exponent for the x minus 1, and I could have any exponent times it for the x plus 2. So that would be the general form for that equation. Okay, lastly, let's look at this example. It says, suppose p of x is a third degree polynomial, and we're given these roots, a -3, 5, and 1/2. We're going to sketch a possible graph for p. So I'm going to start out by, remember these are my roots, which are the same as my x-intercepts. So I'm going to start by graphing my x-intercepts. So -3 and 5 and 1/2 would be right here. So now I can draw any wavy line that's going to go through these 3 points, as long as those are the only points that the graph goes through. Any graph I could come up with would be fine. So I can come up with that one, come up with one like that. You could make it so it's really steep. You do something like that. You could even throw in something funky in there, like that would work. So as long as your graph goes through only those 3 points on the x-axis, you're fine. So hopefully that's starting to make sense. But today, again, we're just looking at how to use that factor theorem a couple of different ways. So good luck on that assignment.